Viral Science, the home of creativity.
Hey friends, welcome back to another video. Today I have an amazing Robo kit. So this is a PiCarX kit sent to me by SunFounder.com. Links to purchase this kit will be in the description so you can check it out. This PiCarX runs on a Raspberry Pi and it can be controlled with a smartphone. It has a camera which can also change its view direction as well. This is a AI based car and it can identify human faces, colors and has multiple features like obstacle detection, age detection, line following. It can also play music and also do some text to speech as well. You can program this robot as per your logic and make use of each and every function this robot has. It is based on Python and if you are good in it then you can easily program this. And if you don't know Python then you can program with eBlocks code, which is very simple to do. Just drag and drop the functions as per your logic and it's done. In this video I will show you how to assemble this robot and we'll test some of its features. So let's get started with this video. So here is the box of the PiCarX. Let's quickly unbox it and see what's inside. So on the top you can see the manual where on the front page all the images of the components is listed, and inside this manual you will find the assembling steps where each and every step is properly mentioned. So if you follow this each and every step you can easily assemble this car, and on the last page you can find the wiring diagram. So with this you can easily make the PiCarX. So let's keep this manual aside for a while and see what's inside the box. So on this top layer you will find the metal chassis of the RoboCar and you will find some wires as well. On the second layer you will find the motors and the wheels and Allen key and some screws to fix this car. And on the third last layer you will find the battery holder, some servo motors, sensors and the PiCar hat and a screwdriver to assemble this. So these were all the components which we found inside the box, and now let's follow the assembling procedure to assemble our RoboCar. So on the very first step it's mentioned to assemble the battery holder. So for that we'll first fix the ribbon as per the diagram. So this is the top main chassis. So here is the ribbon, and this ribbon is used to remove the battery easily. So we have fixed the ribbon as per the diagram, and now we'll place the battery holder. So here is the battery holder and now we'll place it on the chassis, and we are using this M3x4 screws which is mentioned in the assembly manual, and we'll fix this battery holder. So the next step is to fix the standoff. So here is the position, so we'll fix the standoffs over here. So these were the standoffs mentioned. You will find each and every screws and standoffs and other small components labeled inside this plastic bag. So we'll fix the standoffs. The standoffs are used to place the Raspberry Pi over it. So after fixing this we'll fix the motors. So these were all the screws and nuts required. It's mentioned in the manual as well. And here is the motors. So now we'll fix this on the bottom of the chassis. We'll pass out this battery wire from the small hole, so we can connect it with the Pi hat on the top. So now we'll fix this motor and screw it. So I'm using this Allen key to tighten the screws. So now I fixed both the motors and will pass out the wires from the hole behind this. So this step is done. Let's move to the other step. So now we are fixing the standoffs over the Raspberry Pi. So we are using this 2.5x11 standoff, and we are using the Raspberry Pi 4. I am using a 4GB RAM model. So we'll place this Pi on the top of the standoff. After placing it, we'll tighten it up with the other standoff. So the next step is to connect this FFC cable. This is cable used for the camera. So we'll connect it to the camera connector of the Raspberry Pi. So now we'll connect this robot hat on the Raspberry Pi. Make sure you connect all the header pins properly. And to protect this, they have given a case for this Pi hat. So we'll place it above this Pi hat and we'll tighten this up with the screws. So we are using 2.5x14 screws. So we'll properly tighten this up. So in the next step, we have to connect the servo arm, and we are using 1.5x4 screws. So we'll place this from the bottom and we'll tighten this up with the 4 screws. So now we have to connect this ultrasonic sensor with the plate and the rivet. So here is the ultrasonic sensor and this is the plate, and we are using this 3090 rivet. These are the self-locking rivets. So first we'll pass on this ultrasonic sensor, we'll place the back plate, and now we'll pass on the rivet, and with the gentle pressure we'll press this rivet and it will self-lock it. So as you can see, it is locked, so it won't come out. So now we'll fix another standoff on the bottom. So we are using this one. So we'll pass on the screw and rotate the standoff clockwise so it will get tightened up. So as per the manual, the next step is to connect the FFC cable to the camera. So here is the camera module, and we'll connect this FFC cable with the camera. So now we'll connect the camera module with the A3 plate, and we are using this 2x4 screws to fix this. So now we'll connect the servo arm on the A3 plate. With this we can control the tilt of the camera. So after this step, we'll connect the power cable to the Raspberry Pi by this hat, and it's time to upload the OS on our SD card. So here is the SD card. I'm using a 32 gigabits of SD card, and will upload the Raspberry Pi plus EasyBlock OS. So here is the OS. I'll share the link to download this. so you need to download this OS. I already downloaded it. And now you will need this application, that is Raspberry Pi Imager, and with help of this we'll upload this OS into SD card. So first we'll select the OS. So I've selected this downloaded image file. Now we'll select the storage, that will be our 32 gigabits SD card. So make sure you select it properly, and we'll click on this right button and we'll continue. So it will take some time and our OS will be loaded into the SD card. So after this you will find this kind of messages. Just click on OK and you can now remove the SD card. So click on continue and remove the SD card. Now your OS is flashed into this SD card, and now you can plug this SD card into the Raspberry Pi. So now we need to insert the 18650 batteries. These are not provided inside the box, so you need to purchase it separately. So in this way you can connect these batteries. So now the next step is to zero the servos. So for that, power on the Raspberry Pi and it will power the hat system, and wait for some time. And now plug the servo pin to the pin 11 of the Pi hat and it will zero the servo. So to cross check this, you can connect the servo arm on the servo and rotate it to the left side, and again connect it to the pin 11 and it will come to the 0 position. So in this way you have to do this for all the 3 servos. So the next step is to connect the pan and tilt servo to the A2 plate, and we are using M2x4 screws and 2 servo motors to fix this. So now we'll pass the FFC cable of the camera from the middle of the 2 servo motors, and we'll connect the tilt servo with the servo arm which is on the head of the camera. So here is the servo motors, and we'll pass on this FFC cable from it, and we'll connect the tilt servo with the servo arm which is on the head of the camera, and we'll screw it up. So it should look something like this. So now we'll use this washer and connect the pan servo motor. So place this washer on the servo arm and connect the pan servo motor. Make sure it looks straight, and we'll tighten this up with the screw from bottom. So now the next step is to connect the steering servo. So we are using M2x4 screws, and we'll connect this steering servo on this chassis. So the next step is to connect the servo arm with the A7 plate for steering. So we are using M1.5 into 4 screws to connect this. Make sure you don't tighten up the screw. We should keep it a bit free so it can rotate freely. So now we'll connect the steering servo arm which we made with the steering servo motor. So here in the bottom you have to connect it. And we'll tighten this up with the screw so it will not get removed. So now we'll connect this A4 bottom plate with M3 into 6 screws. So now we'll connect the IR grayscale sensor module and we'll use M3 into 6 screws to fix it. So the next step is to connect the A5 plate with the rivet. We are using 3065 rivet. So these are the self-locking rivet. So we are going to use this, and this is the A5 plate. So on these 3 positions we have to fix this plate, and to lock it we are using the rivet. So gently press the rivet and it will get self-locked, and this plate will move freely. So on these 3 positions we'll connect the rivet. So with the help of it, this robot can move left and right direction through the steering servo. So we'll do the same thing on the other side as well. So now we'll connect the wheels. So first we'll connect the front wheels. So we are using 2 hexagonal washers and 1 round washer. So these 2 hexagonal washer will go straight away inside the wheel, and we are using rivet 4120 to fix it. So first we'll place 2 hexagonal washers inside this wheel. Next we'll connect the round washer. Then we'll pass on the rivet from the other side. and then we'll connect it to the A5 plate. So just press it gently and it will get connected. Make sure the wheel turns freely, and yeah, it's moving freely, and we'll do this on the other side as well. So now we'll connect the other two rear wheels. This will easily slide in the motors. So now it's time for the wiring. We are using a 4-pin wire and a 5-pin wire. 4-pin wire is for the ultrasonic sensor and 5-pin wire is for the grayscale module. And we are using these wires to connect on the Pi hat. And we'll also connect the servo wires on the Pi hat according to this circuit diagram. So here is our RoboCar, and we'll connect the connectors which are provided. All the screws, wires are provided extra, so if you lost some of the wires or screws, you will always have some extra pieces so to fix this car. So we have connected this 4-pin wire to the ultrasonic sensor, and we'll connect this 5-pin wire to the grayscale IR module. So these are the servo connections: pan, tilt and steering servo. Make sure you connect it line by line, and these are the motor connections. So we'll pass on this wire from the bottom of the wheels. So first we'll connect the ultrasonic sensor wires. Make sure you connect it according to the diagram. The white pin will go to the D3 pin, the yellow will go to D2, red will go to the 3.3 volt, that is positive connection, and the black will go to the ground, that is a negative ground connection. Similarly, we'll connect the grayscale module wires. So over here the white wire will go to A0, the brown wire will go to A1, yellow wire will go to A2, the red wire will go to 3.3 volt, that is positive connection, and the black wire will go to the ground connection. So in this way we have done the connections of ultrasonic sensor and the grayscale module. So now we'll connect the servo wires. So first we'll connect the pan servo to P0, then we'll connect the tilt servo to P1, and then we'll connect the steering servo to P2. And now we'll connect the motor wires. So we'll connect the left motor with the left one and the right motor with the right connection. So in this way we have completed all the wiring connections as well. So now our Pi car is ready. So we have downloaded this application EZBlock Studio. So we'll open this up. So this is the release note, the version release note. We'll cancel it. So on the top you'll find the connection button. So here we need to connect it. So first we'll turn on the Pi car. So first we'll also need to select the model of the car. So we'll cancel this. Again we'll click and we'll select the change product button, and over here we'll select the PiCarX, and now we'll connect on the connect button. So you can see the IP has found for this car. So we'll click on it and we'll press the done button. So in this way the car will be connected with the application. So since we are using it for the first time, we need to configure it with the Wi-Fi passwords and country name and all the details, which will go to the Raspberry Pi. So after configuration completes, you will get a message, and now we will need to select the product again, and now we'll set the name of our product. So you can set anything. I'm setting PiCarX. So we'll click on confirm, and since we are using it for the first time, we need to calibrate all the servo motors. Calibrate it and make sure you set it to the center position at the proper angle. You can use these buttons to set it to the center position at the proper angle. Since we are confident with the connections, now we'll connect the cable wrap to make all the connections neat and tidy. So now we'll try out some examples on this car. So first we'll try the joystick control. So on the top you will find this. We'll click on the run button, and here is the joystick. We can pause it and we can adjust the joystick. So I'm dragging it towards the left side. I'm controlling with the left arm. So now we can control it very easily with one hand. So now we'll try out the second example where we can also control the camera and view the footage. So here with the joystick you can also change the angle, the direction of the camera, and view the camera in all other directions as well. So now we'll try on the third example, that is bullfight. So in this example the car will follow a red color object. So for a red color object I've tied a cloth on a stick. So where we'll move the stick, the car will follow it. So as you can see, the car is following the stick and the red cloth. So here is the another example. This is color detection. So we'll press on run, and over here it will detect the color of the object placed in front of the camera. So again I'm placing the same red cloth in front of the camera, and it will display the color name. So as soon as I bring the red color in front of the camera, it detects and the name is printed red outside the green box. So now we'll try out another example, that is human face detection. So we'll press on the run button, and now as soon as I bring the camera in front of my face, it detects and creates a blue box. So as you can see, it has detected and it created a blue box, and it can detect multiple faces as well. It can even count the number of faces. It's due to the AI in the car. So now we'll try out next example, that is sound effect and text to speech. So on the top block you can find the word ready written on it. So we'll change this word to viral signs, and as soon as I play the button, it will play the sound.
3, 2, 1. Viral science. 3, 2, 1. Viral science. 3, 2, 1.
So friends, if you like this robot, then do hit that like button, share this video with your friends, and also don't forget to subscribe to my channel for more such videos, and I will see you in the next one.
Do subscribe and press bell icon to get instant notification for new video.